Well, good morning, everyone. Before I start, can I just quickly get a show of hands? How many of you are actually, running serverless workloads right now already? Okay, well, quite a few hands. And how many of you are struggling with getting a reasonable local development experience? A few hands? Okay, yeah, I'm not quite sure, but okay, yeah. So hopefully with this talk, I'll give you some ideas in terms of how you can improve your development workflow when it comes to working with serverless technologies like Lambda, API Gateway, and so on. So I'm not going to take too much time to explain, to introduce myself. My name's Yan. I've been an AWS Serverless hero for a little while, and I've been running workloads on AWS for quite a long time, since 2010. So I've gone through the whole journey of running stuff on EC2 to containers to now mostly focusing pretty much entirely on serverless. Nowadays, I spend half of my time working with Lumigo team as a developer advocate, and the Lumigo is, in my opinion, the best observability platform for serverless workloads, but they also support containers as well, but I don't really run much containers myself. The other half of my time I spend working as an independent consultant, and I help lots of customers adopt serverless. And one of the big questions I get from my clients is, well, how do I get a fast feedback loop of from development to testing so that as I make a code change, I don't have to wait 5 minutes for deployment so that I can test a simple line code change. And there's a common myth that there's just no local development experience when it comes to doing serverless stuff. So I'm here to tell you there's quite a few different options you can apply in, hopefully, depending on your situation, that will help you get a much faster feedback loop between writing code and testing it. The first option is to use the hexagon architecture, which is often called a ports and adapters architecture, because it's an architectural pattern that helps you create loosely coupled application components that can slot into different execution environments by creating these constructs called ports and adapters. And it's usually drawn in a diagram like this one, where you have your core domain logic right at the center there. It's encapsulated away into its own modules and classes and whatnot, and it's hosted inside your application layer. And when your application needs to get data from the outside, or to receive a request, or to, say, get some data from a database, you create the ports that allows the application to talk to the outside world. And then to connect those ports to the outside world, you create adapters. So in this case, if we are building a workload, say an API, and we want to run it inside the Lambda function, we can create a client for our application. And that would be, say, a client specifically for the Lambda functions execution context, so that it was responsible for converting, say, the Lambda's execution argument, event, and a context object into some kind of a domain object that your application understands, like a command to create a user or a query to fetch some data and so on. And if tomorrow we decide that, okay, Lambda is great for us to get started with, to give us a lot of agility when we're starting out, we can change things really quickly. But then now 4 or 5 years down the line, now we're running at pretty high scale. Now we started off with just a few users, and now we've got millions of users and doing thousands of requests per second. Suddenly, Lambda is not that cost efficient, and we no longer need to change your requirements every single day. So think about that Amazon Prime Video article that came out saying, I think last year, how they started with serverless because it gave them fast time to market. But over the time, the system grew and they had a lot more traffic, so they wanted to look for cost efficiency, and so they moved the workload to containers instead. One tidbit in that article where they talk about how, because they had good modularization in place in the code, they didn't have to rewrite the entire application when they make that move. So you can kind of do the same thing by making sure that you've got good encapsulation and modularity in your code. And in this case, to move your workload to, say, a Fargate, you can just create another adapter that adapts to the Fargate execution environment. Maybe you just want to run it inside some kind of a web application framework instead. And so what this hexagon architecture gives you is this nice abstraction that allows you to encapsulate everything in place so that you can easily create portability where you need it. So this could be a case where if management is a little bit worried about, oh, what about vendor lock-in? What happens if you want to move compute to containers later? You have those abstractions in place so that those moves are going to be a lot easier when you do need that. So you can give you a lot of portability and flexibility in terms of where you run your workload. And similarly, if your application domain needs to talk to the outside world to get some data or to, say, save some data into a database, you can create adapters that also talk to, say, databases. In this case, okay, let's start with DynamoDB because it's really simple to use, especially if you're just doing mostly CRUD operations. You can create an adapter for the data ports for your core domain. And maybe tomorrow you decide, you know what, we want to test our code locally. So instead of talking to the real DynamoDB tables, what we can do is we can create a mock that allows us to execute our core domain logic, but against the mock so that we can have a better control over the response from, say, DynamoDB so that we can maybe test different scenarios more easily, especially if you want to test for, say, failure conditions. If your, say, DynamoDB request is getting throttled or you're getting some specific errors that you want to be able to handle, then you can use the mocks in your local development environment instead. Or later on, if you say, okay, we want to switch to RDS because our queries are now getting more and more complex, and we are now just spending most of our time fighting the complexity because DynamoDB is not very good with more complex access patterns. So you can make that change without, again, having to rewrite large parts of your actual application. So ports and adapters or hexagon architectures gives you a lot of flexibility because you have all of these nice abstractions in place, all of these nice encapsulations. And because it's not something specific to a language, it's pretty much universally applicable to any language you want to use, and also any framework that you want to use with your application as well. So if you're using server framework or CDK or SAM or SST or whatever framework you're using, this is all applicable because it's just about how you create that encapsulation in your code. And again, it creates that portability if you later on need to move your workload to a different execution environment. In terms of downside, well, serverless is not just about Lambda functions. Lambda functions, of course, or some kind of a function as a service, like Azure functions as well, is of course a big part of what we consider serverless. But when it comes to serverless, I think of serverless in terms of any technology that means I don't have to manage any servers. I spend maybe 70% of my time back in the day just patching machines and updating machine images and setting scaling configurations, the launch configs, all this other stuff, and networking. So I spend most of my time just doing all of that and managing infrastructure rather than writing the few lines of code that customers actually want from me. So any technology that can save me from all of that grunt work, all of that yak shaving, is going to be a big win for me. And also, ideally, I want something that can scale to 0 with usage-based pricing with no minimum. That means if I've got lots of resources that are created in my account, if nobody's using it, I shouldn't have to pay for them. Whereas for, say, something like RDS cluster or OpenSearch cluster, you have to pay for uptime, even if nobody's using them. These last two are really important for some practices, specifically when it comes to the use of ephemeral environments, which I'm going to talk about later. And it's one of the most impactful practices that's going to help accelerate your development workflow, especially when you work in a big team where lots of people need to be working on different features at the same time. And one of the adages that one of the things we had at the start of the serverless movement or paradigm is that you should use Lambda functions to transform data, so to apply some business logic, but not to transport data. So if all you're doing is taking data from one place and returning it somewhere else, you don't really have, you don't want to have to write those custom code and pay for the Lambda functions and also having to maintain that function and routinely upgrade your, say, runtime and things like that. So imagine nowadays you want to build a REST API. You can do this without having to write any Lambda functions, any custom code, by just plugging API gateway with Cognito for user authentication and authorization. And then you can have actually API gateway talk to DynamoDB directly. So in this case, instead of having a Lambda function sitting in between, just to make a call using the AWS SDK to get some item from DynamoDB, you can have API Gateway do that for you, which means no Lambda function does know all the costs associated with that function in terms of the execution, the time it takes, but also the latency that gets added when you've got, say, Lambda function that needs to cold start occasionally, or just that extra overhead it takes to execute your code to call the DynamoDB for you. And you can go beyond that. So if you want to, say, write something to DynamoDB and you want to trigger some additional processing by first, say, capturing those data events and into your event bus so that you can convert them into domain events, and then that triggers other business logic to say, when a user creates a new order, let's do some other thing, maybe create a voucher for them so that on their next order, they get some discount or something like that. Again, to get your events from DynamoDB, those change events from DynamoDB to EventBridge, you don't have to write custom code nowadays. You can use EventBridge pipes, and then you can use a Lambda function to do the data transformation, and so that your domain events that ends up in EventBridge actually have the right shape and have the right data. EventBridge pipes can also be used to do other things as well, like calling third-party APIs and all of that stuff. And so if you are building services without any Lambda functions, then, well, unfortunately, you don't have any custom code, and so nowhere for you to put those hexagon architectures around your code. So with this approach, where we are focusing on how to modularize our code so we can easily test them, if you don't have custom code, then you can't test your application. So a lot of this direct service integrations kind of falls outside of what you can test and to do with hexagon architectures. And also with hexagon architectures, there's some upfront work you have to do to create those abstraction layers so that you can have that portability later when you need it. So what happens if you do you do mostly what we call functionless? So basically, you try to use the direct service integrations and try to avoid creating custom functions unless you really need to. Then how do you kind of get that local development experience? You can use local simulators, and nowadays, the biggest, I guess, the most popular tool in this space is by far is the local stack. And if you take that example we had earlier, where we have an REST API with just API gateway talking to DynamoDB and EventBridge pipes shuffling data for you, transporting data for you, you can simulate the whole thing locally on your machine using local stack. And one of the things that local stack gives you on top of what you may be able to test in the real AWS environment is that with local stack version 3, they've got a new feature now that allows you to enforce IAM permissions. So in this case, everything that you're asking AWS to do for you, you have to create IAM permissions so that the API gateway has the right permission to DynamoDB, and the EventBridge has the permission to write events into the EventBridge bus. So when you've got a, say, mistake in your code and you forgot to set the permissions correctly, or you just point to the wrong bus or you have a typo in the action, then those IAM permissions are really difficult to debug in the real AWS environment. And one of the value add that you get from local stack is that by enforcing the IAM permissions locally on your machine, when you try to do this, say you run an end-to-end test against the local stack simulation of your API, you're going to see that, okay, there's an error, and it's IAM permission error when the EventBridge pipes try to put events into the event bus. So this is how you can debug some of these permission problems a lot easier and earlier as well before it goes to the real AWS environment. And of course, if you're using Lambda functions to transform your data before it goes into EventBridge bus, then you can also use local stack to simulate that. And I believe you can also put breakpoints in your code as it runs that simulation as well. So the great thing about local simulation is that it's much broader in terms of what you can do with it and what you can test. It's not just about your function anymore, but it's about your actual whole serverless architecture. The downside is that it's still just a simulation. It's never going to be 100% accurate in terms of matching the real environment. Chances are you're going to see some APIs that you use may not be supported, or maybe it behaves slightly different to the real thing. So it's always possible for you to run into problems because the nature of it being a local simulation. And so, okay, what if instead of doing that, and you still want that portability, but you don't want to spend a lot of time to create those abstraction layers? More and more popular pattern nowadays is what we call Lambda Lith, which is basically when you run a web application, say an Express.js application inside the Lambda function. So the way that many of us have been advocating how you build RESTful APIs with a serverless is that you have API gateway at the front, and then every single route and every single method would have a different Lambda function that is single-purposed. But no, that's a lot that's a lot of Lambda functions you have to write and create and manage and maintain. So more and more people are looking for something a bit easier, especially when you're coming from a more traditional web development background. So Lambda Lith has been getting a lot of traction. And nowadays, there's some pretty good tooling to support this way of building serverless APIs as well. So you have the AWS Lambda web adapter, which you can include as part of a Lambda function via Lambda extensions. If you want to use more of a framework to help you develop your function, your application in the first place, then you can also use Serverless Express for Node.js, Breath for PHP, and then there's also Zappa for Python as well. So there's a lot of different tooling that supports this paradigm, this way of building serverless APIs. And the nice thing about this approach is that you're just building Express.js application or Flask application. So it's familiar to most web developers already. And again, because you're just building a web application using your framework of choice, then you can also just run that same web application later inside a container. So once again, it gives you that portability. And you can also bring those familiar test paradigms, how you use to test applications, you to, say, run your web application locally and have it talk to, say, SQLite and for your testing and so on. You can apply those same practices that you're already familiar with. And the downside of this approach is that, once again, it still relies on you creating your entire application using writing custom code. If you want to, again, move more towards the sort of functionless side of things, then and using the services to do most of the work for you, then you won't be able to test those because those are outside of your code. And also, some of these web frameworks are just not designed for the constrained environments that you have with, say, Lambda or other function as a service platforms where you have limited CPU, limited memory space, and also your function instances are created on demand. So if you have got a large dependency for that web framework, then that can have a big impact on your cold start performance as well. And also, a lot of this tooling are sort of geared towards building web APIs. So the Serverless Express, Zappa, everything. So they're mostly geared towards building APIs. But we know for a fact that a lot of the serverless architectures are not APIs. There's a lot of people doing event-driven architecture. So how do you then apply the same practice to those architectures as well? Those paths are not as well defined as when it comes to building APIs. And then the downside with this is that because instead of having single-purpose functions and more granular routes in, say, API gateway, now you just have one route, a greedy route that routes everything to a Lambda function, and you're using the web framework to do the internal routing to different code paths. It means that you have one function, one set of metrics, one set of alerts, and so it becomes harder for you to get that granular visibility into what's going on in your system. Say you've got an alert that says the number of 500 errors is up. Well, is it one endpoint? Is it multiple endpoints? Is it more systemic that everything is being affected? It's really difficult to know that because you don't have those granular metrics and those alerts as well. Of course, you can kind of make up for that yourself by, say, having different code paths just emit those metrics, those custom metrics, so that you can then create those alerts against those. But those are work that you have to do yourself. And also, when you've got a single Lambda functions, it becomes much harder for you to, say, making sure that every single route has just the permission it needs to do that thing. In most cases, it's probably not going to be a big problem. So when it comes to Lambda lifts, I'm more concerned about the lack of granular metrics and alerts that you have to do yourself in order to get the same level of visibility into what's happening in your system. Okay, so what if we just use a framework that gives us some of this tooling already for local development? So serverless framework has the serverless invoke local command you can use to invoke functions locally, and you can do that and put breakpoints in your code so they can execute your function locally and step through it line by line. Same goes to SAM. SAM has a SAM local invoke, and the SST has a SST dev command as well, which does something similar, but instead of running your function locally, you would trigger a remote Lambda function and do some clever webhook stuff to then get the debug points information back to your local machine. So the nice thing about using the framework to do that for you is that, well, it's all there for you already. The framework is doing all the heavy lifting. You don't have to do anything yourself. You don't have to structure your code in a certain way. You don't have to do any sort of clever things. It's all right there in the framework. The downside is it's tied to the framework. And so something, say, something that SAM has added, well, that's great for SAM users, but not for everybody else. And that's why I've been really kind of annoyed with some of the AWS teams whereby they keep talking about developer experience and putting everything into the client side, into the frameworks, as to actually improving the actual services themselves to create tooling that's more broadly applicable to everybody. Every time I jump on a call with someone from the SAM team, I'm like, okay, great, kudos for the new thing they just added, but what about all the other customers who are not using SAM? And again, it's just focusing on testing individual Lambda functions, and it doesn't really help you test your direct integrations that you're using to shuffle data from, say, one service to another. And also, it's great for running your function locally, step things through it as you're making a new change. So it's great for more for the kind of exploratory testing. But you're not gonna do this every time you make a code change and then just manually invoke the functions, every single function you have with different payloads, so that you can exercise all the different code paths that you have in your system. So you still need those automated tests. You still need to know how to write those and execute those in a way that give you that fast feedback loop. So when it comes to writing tests, my favorite approach of writing tests is what I call remote code testing. So this is when you combine elements when you execute your code locally against the remote resources, hence the name remote code. So this approach is basically combining elements of local testing, where you run your code locally so that you have that fast feedback loop. You can put breakpoints in your code. You can step through things when there's more complex problem you need to debug. And so it gives you really fast feedback loop. The problem is that, you tend to have to run this local test or unit test against mocks, which says, okay, does my code works if my assumption about, say, DynamoDB's response is going to be correct? Whereas if you test against a real thing, it's a real thing. So you actually find out if it actually works. Because a lot of times your expectations or assumptions about what this thing that you're mocking away is going to return can be wrong. And I can't tell you how many times I've seen passing tests, everything's green, you deploy, the first time you run it, bang, it fails because, okay, we got a typo in our DynamoDB query syntax. It's a string. We didn't catch the typo. Our mock just says, yep, return the correct answer. So the test passes, but it doesn't really matter if your test passes, if your application is broken. So a lot of times you're really prone to get false positives when it comes to local testing against mocks. And also, it's fairly limited in terms of what you're able to test as well, because the things that often go wrong for me would be, say, misconfigured permissions. I create a new Lambda function to support a new route or do something new, and I forgot to set the permission correctly so that function has the right permission to go to DynamoDB and get some data. Well, I can't really test that with my unit tests. So the confidence I'm able to derive from my tests is fairly low. And your application, as I keep saying, is a lot more than just your custom code, especially if you're going more towards a functionless approach of building applications using serverless technologies. And you kind of have to make sure everything works, not just, okay, my code is working, but all my configuration is wrong. That doesn't really matter to your customers. If your application is not working as expected, then you still have to fix it. So that takes us to, okay, what about just testing everything in the cloud, as many of the AWS, I think, developer advocates will often push you towards doing that. So you're testing against a real thing, so you're going to get realistic results, and it's going to cover everything. So if you got a permission problem with your Lambda function, that's going to show up in those remote tests. So you can get pretty good confidence that whatever the test is telling you is actually accurate. But the problem is, if you have to, say, make a code change, fix a typo, and you have to do a deployment and have to wait another 5 minutes, then of course that's going to be really slow, and it's going to really slow down your feedback loop between making a code change and seeing if it's working as you expect. So the idea of remote code testing is then we take these two things and try to take elements of both in such a way that we will execute our code locally, but we talk to the real thing as much as possible so that we test the integration between our code and, say, DynamoDB. So at least for the happy paths, so that as much as possible, we're hitting the real thing and get good confidence from the test that we're actually running. But because we're executing code locally, we can do this repeatedly without having to wait for deployment. And so we can combine the good confidence from the test with a faster feedback loop. And I'm going to show you in a minute how that's going to look. But for now, I also want to, again, just point out that this line of testing is still just focusing on what's going on inside your Lambda function and your integration from your code to the things that you're talking to downstream. It's still not looking at anything that's happening upstream of your function. So like if you're using API gateway or AppSync to trigger your Lambda function, or using Event Bridge to trigger your function with some event, there's still lots of things that can go wrong there, from IAM permissions to configuring the, say, Event Bridge pattern. Again, I can't tell you how many times I have functions that misconfigured the event pattern so that the function is all correct. If it's given the right event, it's going to do the right thing, but the function never gets triggered because the event pattern's got a typo or has got a wrong structure, so that the event never gets matched by Event Bridge. So in the real AWS environment, function never gets triggered. So it doesn't matter if all your code is 100% correct. If it never gets run at the right time, it doesn't do anything that your customer actually wants. So the nice thing about the remote code testing is, again, it's just how you write your test, how you execute it. So it's applicable to any language or framework you want to use. But once again, you can't test those direct integrations between different services. And so when it comes to testing, I think you still need to have a full suite of different tests depending on what it is you're doing, how you're building it, and what of the service features you're using. So for example, for my Lambda functions, I can use a unit test to test my domain logic. And then for my integration with other services, I can write those integration tests as remote code tests so I can get fast feedback loop on those. And for things like IAM permissions and maybe the permission from API gateway to Lambda, those will be covered by my end-to-end tests as well. And if I'm using API gateway to do all the heavy lifting, say request validation, and then talking to other services, or to transform the response from some integration endpoint, then I have to test those as part of my end-to-end test, because I don't really have a good, or I'm using, say, local stack, so I can write end-to-end tests, but have the test hit the local endpoint instead. But just because you have local simulation, it doesn't mean that your code path is going to get executed. So you still have the right test to trigger those. And for authentication and authorization, again, if it's using Cognito, IAM, API key, and so on, those will all be covered by your end-to-end test. But if you're using a Lambda authorizer, then you could use a Lambda function. If you've got some logic that you need to execute to, say, talk to Auth0 or some third-party provider, or to some internal proprietary identity service, then you can capture those and test those domain logic with unit tests, and then use the remote code tests to execute your function locally against the remote services. So again, depending on what it is you're using in terms of what the service is able to do for you, you may need more end-to-end tests, or more remote code integration tests with remote code testing, or more unit tests if you have a very heavy business domain with lots of business logic. So that's a lot of the theory. Let's talk about how that might look. So I prepared a short demo here to show you. Can you guys see the code okay? Yep, okay. Right, so I've got this project set up. It's I've just deployed earlier. I'm using the server framework here. I've deployed to a new stage called NewCrafts. So this is a temporary environment that I just set up for specifically for today. And in this case, I've got a serverless framework project, and I've got the HTTP REST endpoint set up. And I'm using the server framework to a plugin to configure this particular route to go to DynamoDB table directly. Again, this is where I'm doing letting API Gateway do all the heavy lifting for me. Go to DynamoDB, make a GET request, get the item back, and then by default, that's going to return the DynamoDB JSON structure, which I don't want to return to my caller. So I've got a bit of a VTL code here. I know not everyone's cup of tea to convert the DynamoDB JSON to just regular JSON, but also in the case of, say, the item is not found, instead of returning a null, I want to return a 404 and speak proper HTTP. So I need to do some custom VTL template to support this workload. But then for other things, we want to write a Lambda function to handle those. Maybe there's some business logic I want to capture. There's a add restaurant endpoint, a post endpoint on the restaurant path, which I'm saying, okay, this is an internal endpoint, only internal services can call this. So I'm going to use AWS IAM authentication. But I also want to ask API Gateway to validate the request for me. And the reason why I want to do that, by providing a JSON schema to say the body of the post payload must contain the name, attribute, and it has to be a string. You can set the minimum, maximum length, and so on as well. The reason why I want to do this is because when API Gateway say fails request that doesn't meet the fails request validation, you don't pay for that. Same goes to if the request is unauthorized, you don't pay for that. Whereas if you're using, say, a Lambda function with function URL, any request comes in, if you're doing your own authentication or you're doing your own request validation, then you pay for the request, even if it's invalid. So letting the service do the work for you means that, again, in those cases, you don't pay for those invalid requests. And I've got also some IAM permissions, make sure the function has got the permission to save an item in DynamoDB. And if you look at the code, there's really nothing to it. It's just, again, writing to DynamoDB and returning 202, which suppose, okay, we don't like that. That doesn't make any sense. We shouldn't return 202 because we're returning somebody. So let's change that as part of a feature. So one of the first things we want to do is to write a failing test. So in this case, I've structured my test in my testing so that I've got different test cases. Some of these are only valid for, say, when I do remote code testing. Some of those are only valid when I'm doing end-to-end testing. So I'm using a small library for Jest, which allows you to group your tests in a certain way. And so that when I execute a test, I'm able to execute a test in different contexts. So the schema validation, that's something I'm asking API Gateway to do for me, so there's no custom code. So this only makes sense to run as an end-to-end test. So I marked it as an end-to-end test as such, so that when I have my test script to run end-to-end test, it's only going to test the test cases that are marked with the group of end-to-end. But for my add restaurant endpoint, well, what I can actually do is to say, you know what, when we invoke this add restaurant endpoint, we can run it as a remote code test to test the integration between our code and, say, DynamoDB. But then once it's deployed, it's going to be an HTTP endpoint. We can also run the same test case again by writing our test in such a way that it's high level. It doesn't make any assumptions about implementation details. That if I was to change this to, okay, let's write this, we expected this to return a 200 instead of a 202. What we can do is, as part of this new feature, I've just created a new environment for this. When we invoke add restaurant helper function, it's got just a simple toggle against environment variable called the test mode, so that when the test mode says it's integration, it's going to invoke the function handler directly, locally, with the invocation body and the function name, so that I'm basically just running the function code locally, so that I'm able to verify the code change is working before I deploy the updates to AWS environment, and then run the end-to-end test. So by doing this, I'm now able to, say, bring up a JavaScript, the debug terminal, and I'm able to just say, run this test. I've just updated the test to say I expect the response to come back as 200. So I'm able to run this test, say, and it's going to come back with at least one of the test cases failing, and I made to put breakpoints in my code to say, okay, it is actually working, but I didn't raise the timeout. So if I just remove the breakpoint, it's going to fail anyway because it's a 202. So this test case is going to fail, and if you scroll up, you can see the expected 200 actually received 202. So if we change the code, TDD, start by writing a failing test or updating a failing test, and then make your test pass. So I'm going to fix my code, write my test, and make sure the test passes. So at least have some confidence that my code change is working before I then go ahead. And so because this test case is marked for both integration and end-to-end test, so when I run my end-to-end test, it's going to exercise the same code, but now the end-to-end test is going to fail because the remote endpoint is still returning 202. And so if you look at this failing test, it's going to say expected 200, but got 202 back because we haven't deployed our code change yet. So what we can do is get some good confidence that the code change is working, and then we can then deploy the code changes. In this case, I can say npx serverless deploy, and I set up a new stage. When I start a new feature, first thing I do is I create a new temporary environment. In this case, my temporary environment is called the NewCrafts. And so I create a new temporary environment with my entire application stack so that I'm able to write my remote code tests against this temporary environment, and then get some confidence that my code is actually working. And once I have some confidence that the code change is there, it's fine. But I want to make sure the other things like IAM permissions, any direct service integrations, things like that are still working as well. Then I can deploy to the AWS environment. Or if I'm using local stack, I can change this step and deploy to the local stack environment instead, and then run the end-to-end test version of my test cases. So that in this case, I can then make sure once the deployment finishes, I'm able to run the end-to-end test and see that the actual endpoint itself is also working now as well. So now that the end-to-end, the code has been updated in the AWS environment, I can run the end-to-end test, and now the end-to-end test should also pass as well, which luckily it does. So we got the demo goes up with us today. And so this is kind of the approach, the kind of workflow you can have to be able to combine having good confidence that your code changes are working, and then also making sure that everything else is working with different suites of tests. The downside, of course, is that, okay, you do have to kind of provision those resources, those DynamoDB tables and so on, before you can run your remote code tests by executing your code locally against remote resources. And this is where the use of ephemeral or temporary environments comes in, can also then help boost your development workflow. But before we get on to that, just want to again make sure that you understand, if there's one thing you take away from today, is that there is local development experience, and there's multiple ways you can get that, and you can combine maybe even some of these patterns, say with remote code testing, with local simulation, if you want to have so if you don't have the ability to use temporary environments, then local stack and local simulation might be a good way for you to get that local, that temporary environment that you can use to test and run your code changes in an isolated environment first, before you merge that to, say, your master branch. So last couple of minutes, I want to just touch on environments, how you can set things up. You should, as a rule of thumb, have at least one account per stage, as in dev, test, staging, and so on, at a minimum. So you isolate the different environments from each other, so that if, say, there's a security breach against your dev account, at least the attacker doesn't get access to your production data. And similarly, if you're running a load test in staging, at least it's not going to impact whatever it is you're doing in dev and test or in production. But for larger organizations with lots of different teams, you should even go a step further and have at least one account per team, per environment. That way, you also provide installation between different teams, so that if one team is doing something, service is taking a lot of load, it doesn't impact any other teams. And similarly, if one team has got multiple services, and some of which has got very high throughput or are very business critical, you should also isolate those so that those services have got one account per environment as well. And then on top of that, you can use ephemeral or temporary environments to make development workflow a lot simpler. So we kind of saw that earlier, where when I start a feature, I start by first creating a temporary environment. In this case, I named the environment after my branch, and I'm going to write my code change, make my code changes. I'm going to iterate. I'm going to run my remote code test against that environment. Again, that just exists for me for this feature. And until I'm happy with my code changes, I'm going to submit my PR, and then the CI/CD pipeline is going to run all of my tests. And once I'm done, I can just run the opposite command to remove the temporary environment. That way, once I'm done with this feature, the environment is gone as well. And the nice thing about this approach is that it gives me an insulated environment for my development work, for every single branch and feature I'm working on, or for every developer, so people can work on the same code base simultaneously without stepping on each other's toes. And because you're running all of your intermediate testing against this temporary environment, so you also avoid polluting those shared dev and test environments, which happens a lot. I see a lot of companies have like a monthly script they run to clean up one of the environments, because so much test data gets put in there, it makes the environment unusable. And so by doing most of your development work and testing against these temporary environments, you kind of eliminate the whole problem in the first place. And the nice thing about using serverless components with the temporary environments is that, well, those components give you usage-based pricing. You can have 10 copies of the same application. It wouldn't cost you anything more, because you only pay for them when somebody actually runs stuff against that environment. So you can have as many of those temporary environments as you need, and it wouldn't cost you a dime more than if you had just one. Of course, if you've got the server full components, as in components where you're paying for uptime, then the equation kind of changes a little bit. You wouldn't want to have, say, 10 copies of your RDS cluster for every single environment you've got going on. So that's going to cost you a lot more, because you're paying per hour for every single one of those. So I've put together an article on how to kind of work around that. But the gist of it is that instead of having a different RDS cluster per environment, you would just use the same RDS cluster for the account or for the region. And then what you do is that you create the temporary tables or temporary databases against the same cluster, so that you can consolidate in those lower environments. You can also use the temporary environments to run all of your CI/CD pipeline tests as well. So in this case, when the CI/CD pipeline runs my test, it's going to be executing against a temporary environment that's created based on the SHA of the commit. So that way, those tests again do not pollute my main environment. And I keep saying environments, but environment doesn't necessarily mean an AWS account. In this case, my main stages, my main accounts will be, have one account per each of the main environments. But typically, I'll create my temporary environments for individual developers or features against the dev account, because that's where the team is doing all of this work. And when it comes to environment, it really just means it's potentially different stack. For the server framework, where your application is captured and deployed as a CloudFormation stack. So each environment I'm creating is just going to be a different stack. But for CDK, you can create multiple stacks as part of your CDK application. So it will really just be different CDK application, well, the entire sort of everything that you've got in your CDK application, a different copy of that. Or maybe it's a combination of a few different things. Potentially, you have some dependencies on SSM parameters and other things like that as well. But there's different ways for you to make that work in your environment. And one of the big questions about this is, okay, if you've got all of these copies of the same application in the same account, how can I make sure that my resources don't clash? Number one thing you do is don't explicitly name resources unless you have to. CloudFormation, when it names your resource, it adds some random suffix. So typically, you won't get any name clashes from that. And where you do have to name resource yourself, like EventBridge, EventBus, then just make sure that you include the environment name as part of the name. So either as a prefix or as a suffix. And so this approach works really well with remote code testing, because every developer, when working on a feature, can then just deploy the changes, deploy a stack that allows them to talk to the remote resources from their local code execution. And so I hope I've given you some things to think about in terms of how you can take some of these ideas to improve your workflow when it comes to working with serverless technologies. I know I'm kind of left you just 1 minute for questions, but I'm going to be around, so you can always just come find me afterwards, or reach out to me on social media, or check out my blog, where all the things I've talked about today has also been documented on various blog posts as well. So yeah, thank you guys so much for being here this morning. And again, if you've got any questions, just come find me. Okay, thank you.